In question 4, an electrical heater is placed in an insulated container with 100 grams of ice at minus 14 degrees C. The heater supplies energy at 98 joules per second. In A, after 30 seconds all the ice has reached a temperature of 0 degrees C. We need to find the specific heat capacity of ice. Well, using energy supplied is equal to mass times specific heat capacity times temperature change, we can rearrange for the specific heat capacity, putting in the values given in the question, not forgetting that 100 grams is 0.100 kilograms, and this gives a specific heat capacity of 2100 joules per kilogram per Kelvin. In B, we need to show that the final temperature of the water formed when the heater is left on for a further 500 seconds is about 40 degrees C. We're given the specific heat capacity of water at 4200 joules per kilogram per Kelvin, and the specific latent heat of fusion of water at 3.3 times 10 to the 5 joules per kilogram. Well, the energy supplied will go into melting the ice, given by this expression, plus raising the temperature of the water. Rearranging for the temperature change, putting in the values, we get a figure of 38.1 degrees C, which is around 40 degrees C as required. In C, we're told the procedure is repeated in an uninsulated container in a room at 25 degrees C. We need to state and explain whether the final temperature of the water formed would be higher or lower than that found in part B. Well, the final temperature would be higher, as the contents would be below room temperature for longer than they were above room temperature. When below room temperature, the contents would take in energy from the room. For the shorter time with the contents above room temperature, they would lose energy to the room.